Alright, so let's go through and talk about the information that can be obtained from a balanced chemical equation. And the first thing we notice here is this isn't balanced. I have 2 sodium atoms here and 1 there. So here, these are my reactants and these are my products. So let's take a look at the count for my reactants. I have 2 sodium atoms. I have 1 carbon atom. I have 3 oxygen atoms. I have 1 cobalt atom, and I have 3 chlorine atoms. On the product side, I have 1 sodium atom. I have 1 chlorine atom. I have 2 cobalt atoms, and I have basically 3 carbon atoms and 9 oxygen atoms. Okay, so how do we go about balancing this? Well, the first thing we're going to do is let's take a look at the most complex compound, which is going to be this. Alright, a lot of parts to it. So I have 2 cobalts and I have 1 here. So let's go ahead and put a 2 in front of that. So when I recount, I have 2 cobalts, I have 2 times 3, I have 6 chlorine atoms. So my cobalts are good. Okay. Now let's take a look at my chlorines. I have 6 here, so if I put a 6 here, that gives me 6 chlorine atoms and 6 sodium atoms. Okay, so now my 6 chlorine atoms are balanced, my cobalt's balanced, and now we just have to balance our sodium, carbon, and oxygen. And I have 6 here, I need 6 here, so I'm going to multiply this by 3. Multiply it by 3, I get a 6, so we're putting a 3 as my coefficient out there. Then I have to multiply the carbons by 3, and the oxygens, 3 times 3 is 9. So now, by balancing the sodiums, that works. Balancing the carbons, that's balanced, and the oxygens, that's balanced. With this balanced reaction, what kind of information can we get? What do the coefficients tell us? What the coefficients tell us is this. I need 3 formula units of sodium carbonate. And the 3 of these will completely react with 2 of my cobalt-3 chloride. Okay, if I have fewer of my sodium carbonates or fewer or more of my cobalt chloride, it'd just be left over. And then that's going to give me 6 sodium chlorides. So when the reaction is completely finished, and 1 cobalt-3 carbonate. Okay, so what does that mean? So I'm going to start out with my reactants here. And when the reaction is complete, okay, so when my reaction is complete, all my reactants are gone, and that's all I'm going to have left are my products. Okay, so that's what this reaction tells us when I start out with here and then I end up with here. Now the other thing is this though. If I have 3 moles of my sodium carbonate, then to completely react with the cobalt-3 chloride, I need 2 moles of cobalt 3 chloride. And what that produces is 6 moles of sodium chloride and 1 mole of my cobalt 3 carbonate. Now when we do this, we can get our proportions then. What is the relationship? And we call these things the relationships. You hear us call them about equivalence, or more frequently you'll hear us talk about it as mole to mole ratio. So let's go through and write some of the ratios down. The relationship on the mole-to-mole ratios, the relationship between the sodium carbonate and the cobalt 3 chloride is 3 moles of sodium carbonate is equivalent, okay, it's not equal, it's kind of like you need 4 legs to a chair, right? So the 3 moles of the sodium carbonate is equivalent to the 2 moles of cobalt 3 chloride. Okay, I can also relate this reactant to my products. I can say 3 moles of sodium carbonate in this reaction will produce 6 moles of sodium chloride. Okay, the other thing is we can relate it to our other product. So 3 moles of sodium carbonate can be equivalent to 1 mole of the cobalt 3 carbonate. Okay, so we can relate reactant to reactant, we can relate reactant to products. Okay, what about product to products? Well, we can say if 6 moles of sodium chloride are produced, we also know that 1 mole of cobalt 3 carbonate is also produced. So we can do product to product, we can do reactant to reactant, we can do reactant to products. And of course, you can use your cobalt 3 chloride and make mole-to-mole ratio. So these are all mole-to-mole ratios. Okay, and what we can do with that now is we can use them as conversion factors. Okay, so let's go through and do one example of how you would use your mole-to-mole ratio, and then we'll move on. So, if you completely react (1.5 moles of sodium carbonate), how many moles of cobalt 3 carbonate are formed? Okay. Notice in this question, we are talking about moles, but look at our substances have changed. So whenever you have a change in substance, you know you're going to need a mole-to-mole ratio. So we start off with moles of sodium carbonate. What we want to end it is moles of cobalt 3 carbonate. So what's the relationship between the two? We know the relationship is that for every 1 mole of my cobalt 3 carbonate formed, and we get that from my coefficient here, then we know we're using 3 moles of sodium carbonate. Okay, so my moles of sodium carbonate cancel out, and now my answer will be moles of cobalt, that's a lowercase o, 3 carbonate, and that's going to be 0.5. 0.5. This is 3 significant figures. This is always going to be whole numbers, so these are exact. 0, 0 moles of copper 3 carbonate. And that's how we use the information from our balanced equation.